In this problem, I'm supposed to sketch the graph of a function that has certain properties, and I'm told some stuff here about f prime of x and some stuff about f double prime of x. So the first derivative tells me where the function is increasing or decreasing. The second derivative tells me whether the function is concave up or concave down. So let's see what we've got here. In this first piece of information, I'm told some places where the derivative is equal to 0. So those are going to be critical numbers for the function. So those are possible places where I could have local minima or local maxima. Also, equal to 0, that means then that the tangent line has a slope of 0. So I'm going to have horizontal tangent lines at those points. Here, in the second piece of information, I'm told f prime of x is greater than 0. That means the first derivative is positive. That means the graph is going to be increasing in these places. So as x goes from -2 to 2, it's going to be increasing, and greater than 6, so from 6 to infinity, it's going to be increasing. The next piece of information is the opposite. It says the derivative is less than 0. So that's going to be where the function is decreasing. So if x is less than -2, so from -infinity to -2, and then from 2 to 6. Okay, this next piece of information, the second derivative is greater than 0. So that's the second derivative is positive. That means it's going to be concave up. Less than 0, greater than 4. And the final piece of information, second derivative is less than 0, second derivative is negative. That's going to be concave down. And that's if I'm between 0 and 4. Now, if I'm going to graph this here, I'm not given any information about y coordinates. I have some x coordinates here. We've got -2. Of course, we've got 0, 2, 4, and 6. I'm told here, I know it's increasing, it's decreasing from -infinity to -2. So it's going to have to be coming down to -2, but then it's increasing from -2 to 2. So it's going to have a local minimum at -2. So I'm increasing to 2, but then from 2 to 6 it's decreasing. And then from 6 to infinity it's increasing. I'm also going to have then here, it changes concavity, -infinity to 0, it's concave up, 0 to 4, it's concave down. And then 0 to 4, it's concave down, 4 to infinity, it's concave up. So let's see, what do we have here? We know then, we said it was decreasing till -2 and then increasing. So it's going to have a minimum at -2. And then, so -infinity to -2, it's decreasing. -2 to 2, it's increasing. 2 to 6, then it's decreasing. So it changes from increasing to decreasing at x equals 2. That's going to be a local max. And then here, it's decreasing from 2 to 6, so going down from 2 to 6. But then increasing from 6 to infinity. If it changes from decreasing to increasing, that's a local minimum. So we're going to have a local minimum at 6. And we have inflection points where the concavity changes, and that's here at from -infinity to 0 and 0 to 4. It changes at 0, and then it changes at 4. So those are x coordinates where that stuff's happening. So I don't have exact y coordinates on this graph, so I'm just going to have to make something up. So it's going to be a minimum at -2. So let's put that down here, a local minimum. Okay. We're going to have a local maximum at 2, so it has to increase from -2 to 2. So let's put a point up there. And then another minimum at 6. We could put that here. Those points are relatively random. They don't have to be at those exact points. So I'm going to have it decreasing to -2, increasing to +2, decreasing to 6, and then increasing after 6, right? I got to capture this information here. It's going to be concave up from -infinity to 0. So it's going to be bowl shape up as I come down here to -2 and then come here to 0. But at 0 it has to change and become concave down. So it's going to start being bowl shaped down there, and it's got to go through this point. We have another point of inflection at 4. So it stays concave down, but at 4 here it changes behavior and becomes concave up, and then it increases after 6. So my graph would look something like that. It wouldn't have to be exactly like this, but it would have to have those kinds of qualities and characteristics.